In section 1.4, we're still working with limits, and we're going to focus on both vertical and horizontal asymptotes. So when we have a vertical asymptote, there's really kind of four possible scenarios that are illustrated by these four figures. It doesn't matter where, it doesn't matter for which values of x the asymptote occurs. There's really one of four things that could happen. So if you look at figure 1, we could see where our asymptote, I think for all of these, the asymptote is occurring where x equals 0. But from figure 1, the limit coming in from the left is approaching negative infinity, and the limit from the right is going to positive infinity. So I could write the limit, I'm just going to call this function f of x as x approaches 0 from the left. That limit's going to go to negative infinity, whereas from the right, the limit of f as x approaches 0 from the right, that limit's going to positive infinity. Those are both with figure 1. So then we could observe another possibility is in figure 2. As we approach that vertical asymptote, the limit from the left is going to positive, and the limit from the right is going to negative infinity. I'm not going to write out the limit notation for all of these just yet. In figure 3, we could see both limits from the left and the right would be going to positive infinity as we approach that vertical asymptote. And again, we said that all these vertical asymptotes are occurring at x equals 0. And then lastly, in figure 4, the fourth possible outcome is that both of the parts of the function, both parts of the graph, are headed towards negative infinity as we approach that vertical asymptote from each side. So regardless, for all four of these, at the asymptote, the limit does not exist. So anytime we have a limit that's approaching a number, in fact, you can maybe see in this first limit, I wrote a colon, not an equal sign. Infinity is not a number. So anytime a limit goes to infinity, the limit does not exist. However, for figures 3 and 4, sometimes we will see it written specifically that, like for figure 4, for example, we could say the limit of the function f as x approaches 0, that limit goes to negative infinity. Sometimes we might see a colon or an arrow. We probably won't see an equal sign as negative infinity is not a value. So we could say that about figure 4. We could say that about figure 3. But for figures 1 and 2, since the left and the right limits don't agree anyways, for both of those, we would just say that they do not exist. So those would both be D and E's. Okay, so let's read this next text. So if f has a vertical asymptote at x equals a, we need to find the limit as x approaches a for both sides and determine whether the function f is approaching positive or negative infinity. So let's look at our first limit. And in this first example, if you recall from our last section, the first thing I want you to do every time is to plug it in. So the first thing we want to do is plug in the 3 and try to evaluate the limit. So I'm going to write the limit of x plus 2 over x minus 3 as x approaches 3 equals, so as I plug that in, I've got 3 plus 2 on top and 3 minus 3 on bottom, and we get 5 over 0. So recall the difference between a vertical asymptote and a hole is that for a vertical asymptote, we get a number over 0. So b over 0 is a va, and we said that b can't be 0, whereas 0 over 0 is a whole. All right, so we get this 5 over 0. So now what we need to do is we need to consider the limit from the left and from the right. And this gets a little abstract. We have to hold a lot of this thinking in our head. All right, so let's check the limit from the left. My pen is not working super well. All right, the limit from the left of x plus 2 over x minus 3 as x approaches 3 from the left. So here's the funny thing that we're going to do. We're going to keep the 5 over 0 piece because we already know if we plug 3 in, that's going to be 5 over 0. So I'm going to write that. But we're going to actually mentally plug in just to the denominator a number that's to the left of 3 on the number line. And we want to stay like as close as we can to 3, to the number 3. So like I know an obvious number to the left of 3 on the number line is the number 2. The closer we can stay to 3, the better. So like 2.999 would be a better number to think about. All right, so I'm going to pick a number really close to 3. And again, this is on the left side. So on the left of 3. All right, I'm going to plug that into just the denominator. And all I want to think about is that 0 in the denominator. Are we approaching that 0 from a negative number or from a positive number? So if I plug in the number 2.9 and I just imagine this bottom part and I say, okay, 2.9 minus 3, that is a negative number. So the funny thing we're going to do is we're going to put a negative in front of the 0. I know that 0 cannot be positive or negative, but that's just going to tell us that, hey, this vertical asymptote is coming in from a negative number. So if you think about it, the number 5 divided by the teeniest, tiniest negative number that's a non-zero, that's going to cause that graph to go down towards negative infinity. So like 5 divided by 0, we could think of that as almost infinity, like that's going to be an infinitely large number. So when we divide by that negative 0, and again, we're not really dividing by a negative or a 0, but I know that's going to cause that in behavior to go down. So here's how you could test this really fast. In your calculator, let's see, I don't have mine pulled up, so if it takes a minute to load, sorry, I should have loaded it before I started this video, but it's right here. All right, so in your calculator, if you divide 5 by a teeny tiny negative number, oops, so here's what I mean by that. Do like 5 divided by negative, and then I'm going to do 0.00000000001. We get a negative number that's so large that it has to be written in scientific notation. So that negative 5e to the 10, that's negative 5 times 10 to the 10th power. So that's a huge number that's negative. So that's how we know the left side of this limit is going to negative infinity. All right, so now we want to check the right side. All right, so on the right side, we're going to do the same thing. So I'm going to look at the limit of x plus 2 over x minus 3 as x approaches 3 from the right side. And same as before, I'm going to keep the 5 over 0 piece. Like I'm not trying to come up with different numbers there. All I'm trying to figure out is that a negative tiny number in the denominator or a positive? All right, so on our number line, I know 4 is a number that's safely to the right of 3. Again, I want to stay as close to the 3 as I can. So maybe in my head, I could even just try like 3.1. And this denominator is all I'm worried about. If I think of 3.1 minus 3, that yields a positive number. That's going to be a positive number. So we get this positive 0 on bottom. Because really, as I'm to the right of 3, it's not really a 0 and the top's not really a 5. The top is almost a 5 and the bottom is almost a 0. All right, so when we get that 5 divided by a positive 0, I know that coming in from the right side towards that asymptote, that we're going to be approaching positive infinity. So when we evaluate this limit, The final thing that we can say about it is the limit does not exist, because I can't more specifically say that I'm approaching positive or negative infinity. I can only pretty much say that the limit does not exist. But we'll get to some where we could conclude that it's a positive or a negative infinity. All right, let's try this next one, and I'll do this one a little faster. All right, so evaluate the limit of x minus 1 over x squared as x approaches 0. All right, so we always start these the exact same way. We want to plug it in. We get 0 minus 1 over 0 squared, which is negative 1 over 0. So I'm not going to change that negative 1. I'm not going to mess with the numerator at all. I'm going to imagine the denominator from the left and the right. All right, so if I go to the left, I don't know why this pen is like not letting me change ink. All right, I guess we're still just writing in blue. It'll be fine. As from the left, as I approach 0 from the left side of my number line. All right, so again, I'm not going to mess with the negative 1 or the 0. I'm just going to think about what is a number to the left of 0 on the number line. I know negative 1 would work, and I don't think it'll really matter in this case. If I square negative 1, because my denominator is x squared, if I square that number, I get a positive number. So when I'm to the left of 0 on the number line, even if I'm closer to 0, like negative 1/10, for example, when I square that, I get a positive number. So I have a negative divided by a positive. So if I think about that, a negative divided by a positive is still a negative number. So this is going down towards negative infinity. All right, my limit from the right, so same thing, I'm going to keep my negative 1 over 0. All right, so the negative 1 never changes. But from the right, if I think about, all right, what's the number that's just to the right of 0 on the number line? I could use 1, but again, I really want to stay closer to 0. So just let's imagine positive 1/10. If I square, because the denominator is x squared, if I square positive 1/10, I get a smaller number, but it's still positive 1/100th. So my denominator is still a positive 0. And when I say a positive 0, I mean approaching 0 from the positive numbers. So because my fraction is a negative divided by a positive, because the numerator is negative, from the right, this is still going to negative infinity. If the 0 on bottom were negative, it would go to positive infinity because it would be a negative divided by a positive number. So for all of these vertical asymptotes, while we could say the limit does not exist, what we could say more specifically about this one is that the limit as x approaches 0 of x minus 1 over x squared, that limit goes to negative infinity. And here's how they'll get you on like the AP exam, is they'll ask you a question like this in the multiple choice, and does not exist won't be an answer choice. So you would probably have a positive infinity, a negative infinity. My guess is they would give you 0 as one of the choices. I don't know what the other choices would be. But if does not exist is not a choice, we have to know that this is actually headed towards negative infinity.